So in this question we are given three functions f, g, and h, and all of them are twice differentiable, and g of 2 equals to h of 2 and equal to 4. And we are given that the line, this line is tangent to both the graph of g and the graph of h at x equal 2 at both points. So find the derivative of h at point 2. And so because this line is tangent to the graph of h at 2, that's actually the slope of this line is the derivative of this function. So h prime of 2 is equal to 2/3. And this is our final answer. So in this question we are given yet another function a, which is a product of 3x cubed times h of x. We need to write an expression for its derivative and find its value at x equal 2. So what is the derivative of a of x? It's a derivative of 3x cubed h of x with respect to x, and let's use product rule here. So it will be 9x squared times h of x plus 3x cubed times the derivative of h. And so all we need to do now is to plug in values. So x equal 2, h of x equals 4 because x equal 2, and then the derivative is 2/3 we found in part A. So this is equal to 9 times 4 times 4 plus 3 times 8 times 2/3. And so this is equal to 9 times 4 times 4, 9 times 16, 144, plus 24 times 2/3 is 16, and so this is overall 160. And so 160 is our final answer. In this question we are given the relationship between function h and function f of x, and it's true for all x not equal to 2, and we also know that the limit of h of x can be evaluated using the L'Hopital rule at the value x equals 2. And so we need to use this limit to find both f of 2 and its first derivative. So because h is differentiable, it's also continuous, and therefore the limit as x goes to 2 of h of x is equal to the value of the function at that point, and we know this is equal to 4. This is given to us here. And so also this limit is equal to limit, as we have this function here, as x goes to 2, x squared minus 4 over 1 minus f of x cubed. But we see that when x equal to 2, the numerator is 0. So it must be that the denominator is also, the numerator and denominator both are 0. So from here it follows that f of x cubed is equal to 1, which implies that f of x at the point x equal to 2 equals to 1. So we found f of 2. Now how do we find f prime at the point 2? So because f is differentiable, twice differentiable, f prime is also continuous and differentiable. So it means that the limit as x goes to 2, f prime of x should be equal to f prime of 2, and so this is true. The limit exists and the relationship is true. And so let's use L'Hopital rule here and find this limit. So the limit of the function as x goes to 2 of the function h of x, which is our expression x squared minus 4, 1 minus f of x cubed. We need to differentiate both numerator and denominator. And so this is limit as x goes to 2. In the numerator we have 2x. In the denominator we have 1 disappears, we have negative 3 f of x squared times the derivative of f of x. And so this has to be, let's plug in the values. 2 here will have 4 divided by negative 3 times f of x is equal to 1, so this is 1 squared times what we need to find f prime of x. At the same time, we know that this limit is equal to h of 2, which is 4. So the only variable here which remains is f prime of x, and we can multiply by all of this, divide by 4, and we can find that f prime of x is equal to negative 1/3. And this is our final answer. In this last part of the question, we know that g of x is less than or equal than h of x for all x's between 1 and 3. And then there is another function k of x such that it's always greater than or equal than function g and less than or equal to function h of x for that same interval. The question is whether this new function is continuous at x equal 2. And so let's first notice that because g and h are differentiable and they are continuous because of that, so the limit as x goes to 2 of g of x is equal to g of 2. The limit exists and it's equal to the value of the function, and g of 2 we know is equal to 4. And similarly, limit as x goes to 2 of h of 2 equal h of x is equal to h of 2, which is also equal to 4. Now, because we have this relationship, it follows from the squeeze theorem that the limit x goes to 2 of k of x is equal to 4 as well, because k of x is squeezed between these two functions and the limits are equal, the same limit, so it is squeezed. But also we know that g of 2 is less than or equal than k of 2, less than or equal than h of 2. But these two values are equal to the same number 4, which implies from here that k of 2 is equal to 4. And so you see now that we actually showed that the limit of the function at 2 exists and it equal to the value of the function. So therefore it means that k is continuous at x equal 2. So this completes the proof. Thank you, and I will see you in the next video.